This lesson is on arc length. The first thing I'm going to do is define arc length, actually tell you what it is, make the connection between circumference and arc length, model some examples of finding arc length, and then explain to you what the difference is between rounding and finding an exact length, meaning leaving it in terms of pi. So arc length is actually just a fraction of a circle's circumference. So recently we went over that circumference, what it is, it measures all the way around the circle, okay? For example, if I were to cut it right here and lay this flat, it would measure the length of that line. When we're talking about arc length, though, we're talking about the fraction of it, or a part. Okay, so in this case, we can find the arc length of this guy. We only want to know how much this piece length is instead of the whole thing. So circumference gives you the length of the entire circle, right? As if it was one large arc, okay? And arc length just gives you the part that you're looking for, kind of like a piece of pizza. So circumference we wrote down last time is 2 pi r. Meaning 2 times pi times the radius. To find arc length, it's very similar. We take the circumference formula and we actually multiply by theta over 360, where this is actually the measurement of the arc. Okay, and if you remember from last time, an arc has to be in degrees if we're measuring it. So when we're talking about the measure, we're talking about degrees. When we're talking about arc length, we're talking about something different. We're talking about the measurement in meters, centimeters, feet, whatever it may be, whereas the measure of an arc is in degrees. So looking at this first example here, we're going to find the length of each arc. So I'm going to do 2 examples for you. We're going to leave our answer in both terms of pi as well as rounding to the nearest tenth. So we want to find the length of arc xy. So we know it's the minor arc. We want to be going the other way because it's using only 2 letters. So the first thing we need to know is what formula we're going to use. Well, we saw that the length of arc xy is the same as 2 pi radius times theta over 360. We need to be able to substitute for these 2 things. Okay? We need to substitute for r, and we need to substitute for theta. R stands for the radius. Looking at this picture, I can see that the diameter is 16. Let's change this color. This is 16. That's not the radius. We need to cut that in half, so this is going to be 8 inches. Theta is talking about the measurement of the arc. And because the central angle here is 90 degrees, this would also have to be 90, right? Because that box tells me it's a right angle. So this would be 90 degrees. And now we would substitute. We have 2 pi times r, which we know is the radius. Okay, so that would be times 8 times the angle measurement, which we just said was 90, okay, 90 over 360. We're going to leave one answer in terms of pi and one rounded to the nearest tenth. When you're rounding, you put everything into your calculator. So I would go back to my calculator. I strongly suggest this app. I think it's the Desmos app. Desmos Scientific Calculator. We have 2 times 8 times pi, which is somewhere over here, times 90 over 360. And you can just put everything into your calculator when we're just rounding to the nearest tenth. We get 12.56, so that would be 12.6. So my rounded answer, is going to be 12 12.6, and then the units is inches. So I know from point X to point Y, if I were to cut this part off, okay, lay it flat, it measures 12.6 inches. If we want an exact answer, which we'll write in red in terms of pi, okay, we'll do that one next. What we do here is we put everything into the calculator except the pi. So I'll show you here. Go back to your calculator. We have 2 times pi, which we're going to ignore, times 8 times 90 over 360. We get that it equals 4. So this answer would be 4, then pi inches. Okay. So this is an exact answer in red because we know that pi goes on infinitely. It goes on forever and ever and ever. And the idea here is that this is an exact answer in red because we know that it's 4 pi inches, whereas 12.6 is just an approximation. All right, next question. We're going to find the length of this arc, and this time it's arc XPY. Because it's listed with 3 letters, we know it is the major arc, right? We're starting with X, Y are our endpoints. It goes through P, so it would be this way. We start off with our equation. The length of arc XPY would be 2 pi r theta over 360. We need to substitute for these things. We need to know what r is, meaning the radius. We need to know what theta is, meaning the arc measure. Okay, so let's check this out. The radius, right, is what we're looking for. It's 15. It's telling us that x to O is 15 centimeters. I'm going to substitute in for r when I see that. The degree of the measurement of the arc is 240 degrees. Okay? In the previous problem, they told us what the central angles measurement are, but we know that central angles and arc measures are equal to each other. So if this is 240, this angle measures 240, and on the other part, because we knew that the central angle is 90 degrees, the arc measures 90 degrees. So we are going to have to substitute. We're going to just substitute for the things that we know. So we have 2 pi times the radius, which is 15, times 240 over 360. This is the circumference, 2 pi times 15, and this 240 over 360 tells me what fraction of the circumference I want. So if we're looking for a rounded answer, let's see, and change the color here. If we want the rounded, or we'll do terms of pi first. We want a terms of pi answer. The first thing you're going to do is go to your calculator, put everything in the calculator except the pi button, right? So I would do 2 times pi, but we don't want to put pi in because we're leaving it in terms of pi. We just tack the pi in at the end. 2 times 15 times, I forgot the degree measurement, 240, oops, go back, 240 over 360. Hit enter. We get 220. Okay. So we know that if I was leaving my answers in terms of pi, I have 20. We tack the pi in at the end, and then the measurement that we use, the units, is centimeters. So my exact answer is 20 pi. The next answer is going to be an approximation. Okay. And we'll say this one is in, let's do blue, nearest 10. So if we want the approximation answer, this is when we put pi into our calculator. For rounding, for approximating, this is what's happening. So you do the same steps, except this time we're going to put pi into the calculator. 2 times pi times 15 times 240 over 360. I get 62.83, which would round to 62.8. Oops. Sorry. 62.8. And again, it's centimeters. Arc length, the units, we use is centimeters. Arc measure is degrees. Okay, next page. So I'm going to ask that you pause your video now to find the length of a semicircle with a radius of 1.3 meters. Leave your answers just in terms of pi, so you don't have to round this time. You don't have to find both answers. So pause your video, and when you're ready, unpause to see if you did it right. Okay, so the first thing you want to start off with is your formula, which we know is 2 pi r times theta over 360. We need to know two things. We need to know what the radius is, and we need to know what the arc measure is. So the radius is 1.3. The arc measure, when I read this problem, I notice that there's no degree measurement. It doesn't tell me that the arc measures X a number of degrees, right? But I do notice that it says find the length of a semicircle. A semicircle means a half a circle, okay? So that would mean that it's half of the circle. How many degrees would half the circle be? That would be 180 degrees, because 360 divided by 2 is 180. Now I substitute. So we have 2 pi times the radius 1.3 times 180 over 360. We're leaving it in terms of pi, so we're putting everything into our calculator except the pi button. So you do 2 times 1.3 times 180 over 360. Enter. You get 1.3. Makes sense, right? 2 times this word reduced to 1/2. 2 times 1/2 is just 1. 1 times 1.3 is 1.3. So I write 1.3. I tack that pi on at the bottom. This tells me that this is an exact answer. I did not round. Okay. And the units we would use is the units seen in the radius, which is meters. So your answer should be 1.3 meters.